For the last two examples, we are going to use a given rational function and we're going to graph it. So I want to find the x-intercept. I want to find the y-intercepts. I want to find the horizontal asymptote, the vertical asymptotes, behavior at each x-intercept, and the behavior around each vertical asymptote. So my cool sticky note from a long time ago, I'm going to use, we need to also look at the horizontal asymptote, asymptote, okay, and then we're also going to look at the behavior around the asymptote. Around it. And we should be recognizing that we can pull the domain from the vertical asymptotes. So looking at that, how do I find my x-intercepts? I'm going to grab I'm going to grab my numerator and I'm going to set that thing equal to 0 and I'm going to solve. So again, it's no longer equal to f of x, it's equal to 0. And so I'm going to take each factor and set it equal to 0. So I'm going to subtract 1. I have a solution at -1, or an intercept, or a 0, or a root, or whatever we want to call it. So we are going to graph using red. So I have one at -1. There it is. And I've got one at 5. So here's 1, 2, 3, 4, 5. And then the behavior at each intercept, well, this is a 1 and this is a 1, which means it's just going to cut straight through. It will cut straight through. So that was my x-intercepts. Now let's do the y-intercept. Okay, so my y-intercept means I am going to -1, 0, and 5, 0. All right, so for my y-intercept, I'm going to sub in a 0 for my x's, and I'm going to see what pops out. So I have a 0 plus 1. I have a 0 minus 5 over a 0 minus 2, 0 plus 4. So I have a 1 times a -5 over a -2 times a 4. So I get a -5 over a -8, which is 5/8. So at 0, 5/8. Well, if 4/8 is a half, then this is just a little bit more than a half. Okay? So that's my x-intercepts. That's my y-intercept. Now we're going to do vertical asymptotes. So for vertical asymptotes, we are going to grab the denominator and say what will make u be undefined, which means what will make u be 0. So notice I've usually been putting a not equal to 0 because I've been referring to domain. Well, now I'm going to put equals 0 because I'm dealing with vertical asymptotes. So I've got x minus 2 can be 0 and x plus 4 can be 0. So add 2. So x can be 2, -4, -4, or x can be -4. So these are where my vertical asymptotes are. That's where x doesn't exist. Okay, so for my domain, I would not include 2. I would not include -4. But I've got, let's do my y-intercept is roughly right there. Okay, and then I've got a vertical asymptote at 2. So here's my cool little vertical asymptote. And then I've got one, at -4. So here's 1, 2, 3, 4. So I've got another vertical asymptote at x equals -4. There we go. All right. So I have addressed the x-intercepts, the y-intercept, the vertical asymptotes. Well, now I need to do the horizontal asymptote. So looking at this, I have a horizontal asymptote. My numerator is an x squared and my denominator is an x squared. So since that's a same over a same, I have a horizontal asymptote at y equals 0. So there is my horizontal asymptote. And now what is my behavior around the intercepts? Well, this is an x to the first. So my function is going to be shooting off on either side. And this is an x to the first. So my function is going to be shooting off on either side. In other words, on either side of here, it's going to be going in opposite directions. on either side of here. It's going to be going in opposite directions. And there is nothing keeping you from graphing an additional point or two. So if I wanted to grab an additional point, like what's going on over here? Okay, what's going on over here is, let's grab, this was a -4, so let's grab a -10 and see what's happening. So if I plug in an x of -10, I will be able to see very large numbers, probably not the best idea. So -10, -10 plus 4. So what I'm going to get is a -10 plus 9 is -1 times -15 over -12 times -6. Okay, so I get a positive 15 over a positive 72, which is a big number. Positive 15 over positive 72 is a positive number. So I used a -10, and I'm up in imaginary, or I'm up, what? Why does my mouth not know how to work? So that's going to go this direction, because remember the behavior around the vertical asymptotes, they're going to shoot off in opposite directions. So now I'm going to bring this one down, and I'm going to curve it up that way. And then on either side of the asymptote, it's got to go in opposite directions. So I'm going to curve it down this way. So that is a rough sketch on what this graph looks like. For our final example, we're going to have to do a little bit of factoring first. So I have f of x equals a -3x squared plus 7x minus 2 over an x squared plus a 2x minus 8. So I'm going to factor first. So the bottom, I need two numbers that multiply to -8 that add up to 2. So it's going to be x plus 4, x minus 2. For my numerator, I'm going to have to use the AC method. So I have, after making sure that I've done this correctly, I have a -3x squared times a -2. So that gives me a positive 6x squared. So I need two numbers that multiply to 6x squared that add up to 7x. So it's going to be a 6x and a 1x. So when I go to factor this, I'll have a -3x squared, a positive 6x, a positive 1x minus 2. So I can pull out a -3x, and that's going to leave me with x minus 2. I can pull out a 1, which leaves me with x minus 2. And then I have what is in parentheses, what is not in parentheses. So my numerator becomes x minus 2 and -3x plus 1. Okay, so I know that this is a same over a same. It was a same over here, which means my horizontal asymptote is at y equals 0. Now I can figure out my x-intercepts. So my x-intercepts are going to be the numerator set equal to 0. So I've got an x minus 2 times a -3x plus 1. So x minus 2 can be 0, which would be x equals 2. -3x plus 1 can equal 0. So a -3x would equal a -1, or x would be a positive 1/3. So my x-intercepts are at 1/3, 0, and again at 2, 0. So my pretty picture is going to be over here. I know I've got a horizontal asymptote at y equals 0. So he's going to guide my graph. I know that I've got an x-intercept at positive 1/3, which is right about there. And I got a positive intercept at 2. There we go. So let's look at our zeros, meaning, you're like, hopefully, she just said zeros. Yes, but I meant I'm going to shove a 0 in, and I'm going to see what pops out. So if I do it in this one, I'll get a -3 times 0 squared plus 7 times 0 minus 2 over 0 squared plus 2 times 0 minus 8. So those all go to 0, so I'm left with a -2 over a -8, which is positive 2/8, which is 1/4. So I've got a y-intercept at positive 1/4. Good heavens to Betsy. This is really tight. Okay, so now I need to know, I've done my x-intercepts, I've done my y-intercept, I did my horizontal asymptotes. I know that the behavior around each vertical asymptote is going to be shooting off in opposite directions because these are each of degree 1. So all that's left is for me to find my vertical asymptotes. So to find my vertical asymptotes, I'm going to grab my denominator, vertical asymptote. Okay, so I've got my denominator of x plus 4 times x minus 2 could be 0. And again, we're in the same situation. If I was finding domain, I would say it cannot be 0. But I'm finding equations for vertical asymptotes, so I say it equals. So I've got 2 vertical asymptotes, one at positive 2 and one at negative 4. So here's my negative 4. So here, 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 and here's my 2. Okay, so my behavior around, first of all, notice that your y-intercept then drops down to your x-intercept. So that's a good way of thinking that you're going to be going like this. And then because this denominator, each factor was of degree 1, if it's going up into the, or up into positive infinity on the right, it's going to be going down to negative infinity on the left. If it's going down on this side, it's going to be going up on this side. So I completely forgot how to draw up. All right, so there you go. All right, so that is your very, very, very rough sketch. And I would have all of those bits and pieces labeled. And there you go.